I was saying the Ohm's law was quite good, and the calculations were very good. The handwritten lab report was found to be lacking in parts, lacking, missing things, such as graphs, such as neat graphs. Don't think I didn't notice your graph.
I use like.
Yeah.
I did them in Excel, and
The
I
handwritten?
copied them, and then I copied them.
Yeah, but he didn't. It looks like he didn't even use a ruler.
Ruler?
Yeah, did you use a ruler?
But I have hand.
Can you draw straight line without?
Yeah, because
Okay.
Really? Really? Let's see what a straight line looks like, shall we?
No, this is.
No, you brought it up. You
Yeah,
brought
well,
it up.
yeah, no, yes.
It's gonna hurt my eyes, I swear.
Don't wear glasses. Okay, don't wear glasses.
Yeah, tell me how straight that is now, would you?
It shouldn't be straight still.
Oh well, the axis should be straight at least.
Yeah.
Oh my gosh,
Tell me how straight that is, would you?
The axis doesn't work, Steven.
Oh.
I just
Graph stands on axis.
And these graphs don't even have numbers on them, do they? Where's the units? They're unit-free graphs, are they? Yeah. At least this one has the units. So, before you start talking about people who didn't draw graphs...
What the same thing.
Oh, there's some people worse than me. That's good.
Yes, actually.
No, drawing graphs is better, I don't think.
Yeah, but at least I tried.
No, funny enough, that's actually better than not drawing graphs, okay?
Something is better than nothing.
Yeah.
Try it, can you?
But I don't think you tried hard enough.
Don't push it.
No. Alright, let's have a look at this homework. So, fields, no, not this one, this one. Okay, can we see okay? Yeah. Alright, so the first question, yeah, I think it was a multi-part one, but at least I think each calculation was short enough. So can you just read out the parts to me as we go along? What have we got? Yeah, you've got an electron going around a proton. That's the idea, isn't it? So what the distance is 10 to the minus 10, and the charge is electron and minus electron. It's a proton and an electron. Anyways, what's the first question?
What is the electric
Field strength.
of the electron?
So the formula is 1 over 4 pi epsilon 0 q over r squared, isn't it?
Yeah.
So I just put literally all the numbers in. 1 over 4 pi, what number is the, oh my lid's over there. What number is the epsilon 0? Thank you. It's constant number 32. Yeah, and then we have. Okay, KJ, I'm tired. Leave me alone. All right. 4 pi epsilon 0, which is 32, as you remembered, of course. And then the charge is which one, KJ?
E.
23. That's right. And then the distance is 10 to the minus 20 because it's 10 to the minus 10
No, it was
squared.
meters.
This is meters, isn't it?
Yes.
Yeah, so 10 to the power of minus 20.
Okay.
Yeah. So if you crunch those numbers in, you get 1.44 times 10 to the 11 newtons per coulomb. What do I ask you in part B? Are you writing this down? Come on.
Yeah.
What am I asking you in part B, KJ?
The force.
Okay, so force equals QE, yeah. So if I just multiply this answer by the electron charge, I'll get 2.31 times 10 to the minus 8 newtons. Okay, what do I want in the next part?
Acceleration.
So you have MA equals F, so A equals F
10 to the power minus what?
8.
Just 8.
So then you have F divided by the mass of an electron, which is 3. So this comes out at 2.53 times 10 to the 22 meters per second squared. Now what do I ask you for next in D?
The periodic time.
Is it?
Yes.
Which is 2 pi over omega.
Well, we have to find omega first.
Yeah, actually, yeah, you have to do a bit of do I ask for the periodic time? Are you sure?
Yes.
Periodic time of.
Yeah, okay. So you have F equals m omega squared or. So omega equals square root F m over or. So I have I have those numbers. Square root force times mass divided by radius. So I got here omega is 1.45 times 10 to the minus 14. So the time is 2 pi over omega, which is 4.33 times 10 to the 14 seconds. Ah, my mistake. My formula's wrong back here, sorry. It's F over m or. Let's try that again. Square root
Yes.
force, which is 2.31 times 10 to the power of minus 8, over mass, which is constant number 3, times the radius.
What's the value for the epsilon?
It's on the calculator, I don't remember it off the top of my head. 1.59 times. This number's still looking wrong.
Is it 1.52 times 10 to the power 16?
Yeah,
That's what I got.
alright. So the time is 2 pi over. Oh, so the time will be tiny, which it should be, because it's really gone fast. So 2 pi over answer. So yeah, you get time as 3.9 times 10 to the minus 16 seconds.
Yes.
Okay, what's part E?
Find the electric field charge of the proton this time.
Yeah, so this time you're looking at the field here provided by the electron. So the field is going like this towards the electron. So the proton is being pulled towards the electron this time. So I asked for the strength, but you get the same answer.
So with a minus.
Yeah, with a minus. I'll leave the minus out for the moment, but you get the same answer. What's the next part? Force, is it?
Yes, force.
Which equals QE.
Yes.
But the charge of the proton's the same, so
The same force?
you get the same force. No, 2.31. What's the next part?
Why same first?
Well, it's the same charge of a proton,
Okay.
and it's the same electric field strength.
Okay.
So the numbers are the same. And what do I ask you for in G?
Acceleration experiment.
Now this is where it's different. F equals ma
Yes.
means A equals F over m. So when you take this answer and divide it by the mass of a proton, you get a different acceleration.
What's the mass of a proton?
Again, I gave it to you and it's on the calculator as constant number 1.
1.67
times 10 to the power minus.
Uh,
No, I didn't write the minus part, so it's fine.
Here, I'll tell you it now. It is 1.67 times 10 to the minus 27. So here you get an acceleration of 1.38 times 10 to the 19th. Now, when you compare that answer, look, I know that looks like a big answer, and it is a big answer, but when you compare this answer to the answer you got for, where is it now? Here, the acceleration of the electron, you see it's 1,000 times smaller. So that means the acceleration of the electron is 1,000 times bigger than the acceleration of the proton. So this is why the proton doesn't really move compared to the electron. Compared to the electron, the proton's acceleration is 1,000 times smaller. So it's almost like the proton's not moving and the electron is zipping around it really fast. Well, it's going around it really fast, but the proton is also being pulled towards the electron. So, no, what's happening is this is going really fast, but the proton is vibrating in the center really fast. But it's 1,000 times less the acceleration. So, compared to the electron has an acceleration 1,000 times bigger to the proton. So, if you were the electron, it almost looks like the proton's not really accelerating because you're accelerating 1,000 times faster. So this is why in these diagrams we can imagine the proton is not moving, because compared to what else is happening, it's not really moving. It's the same, we'll see this again in a different thing later. Okay. Number two, two horizontal plates are a distance 10 apart. What is the voltage, with a voltage of a kilovolt, what charge would you need on a gram to keep it balanced between the plates? So what's happening here, you've got your two plates, and there's a downward force here of mg, but it's a gram, so the force is only 0.001 g. There's an up force here, equal to what? What's the formula for the up force here? QE, yeah, or EQ, yeah. But you actually know what the E is, because you have a formula for the E. What's the formula for the E? V over D. Now what's the V? 1,000. And what's the D? 0.01. So the E is 1,000,000 newtons per coulomb. That's 1, 2, 3, 4, 5. E is 10 to the 5 newtons per coulomb. So you just have to say you want them balanced. So QE equals 0.001 G. So Q equals 0.0001 G divided by 10 to the 5. 0.0001 times 9.81 divided by 10 power 5. So you get 9. Which zero now? Did I? Oh, sorry, I got too many zeros now, don't I?
Yeah.
On the top here, 001 G.
2 zeros.
Yes, over 10 to the 5.
Yeah.
9.81 10 to the power minus 8.
Yeah, 9.81 times 10 to the minus 8 coulombs. Or if we, if you want, that would be the same thing as 98.1 nanocoulombs. Okay. Cool.
Number 3.
Huh?
The third one.
Okay. Third one. In this one here, what you have is two vertical electric plates, and they're a distance of 30 centimeters apart. And they're 10 meters long. And there's some dust rising up through the stacks at a constant speed. So what's happening here? You see these in factories. You notice with factories, they have these long chimney stacks.
Yeah.
Often this is to keep the air a little cleaner, because what will happen is inside the chimney there are two electric plates, and when the dust and smoke rise, I think dust and smoke has a negative charge, so it gets attracted to the plates. So the dirt sticks to the plates. And then at the end of the day, when they turn the machine off, you have all this dirt from the smoke stuck to the plate. Then a hammer hits the bottom of the plate and they vibrate, and all the dust falls back down, and then they capture it. So this prevents some of the dirt from the smoke being released in the air. Okay? Because you'd rather have it all contained in one spot than having it spread throughout the city. So it is a way to keep it a little cleaner. Okay, so it is a real thing. So for your problem, what you have is you want to know what should be the voltage so that you can try and get all the dirt. So in the worst case scenario, there's plus, there's minus. In the absolute worst case scenario, the dirt starts on the negative side. Now, if the dirt is negatively charged, will it move left or right?
Right.
Left.
No, you said less is minus. If you
Yes,
say
right.
less.
So if the dirt started here, it will quickly go to the positive. So in the worst case scenario, it starts over here, and as it rises, it's slowly pulled to the left. And what you want is it to hit the plate before it exits. So the question is, how much time do we have? Well, it's rising at a speed of 0.5 meter per second. You see there? So how many seconds do you have until the smoke has left the chimney? Thank you. 20 seconds. Right?
Yeah.
Because it's 10 meters tall. You have 20 seconds. Now, is there any vertical forces acting on the dust? No, because I tell you it's moving at a constant speed. So from Newton's first law, this means the up forces on the smoke and the down forces cancel, they're balanced. So what is the only force acting on this dirt? The electric field, which is pulling it to the left. So what you want is you want this electron to move from right to left in 20 seconds. So you have a UVATS problem. The U horizontally is 0. The V we don't know, the A we don't know, the T we do know needs to be 20, and the S, what's the S?
10 meters.
No, we're looking vertical.
0.3.
0.3. So let's calculate the A. S equals UT plus 1/2 AT squared. The U is 0. 0.3 equals 1/2 A 20 squared. So you get 200. So 0.3 over 200 is what you need for the A. So that would be divided it's going to be small, really small. It's going to be A is equal to 0.0015 meters per second squared. That's the A, isn't it? Yeah, it is. Fine. So how can we get the voltage? Well, now we use Newton. So what does F equal? MA. But what is the F here? What's the formula for the F here if it's in a field? Yeah. QE equals MA. Do we know the M? We do. Do we know the A? We do. And do we know the Q? We do. So we can get the E now. E equals MA over Q. Okay, what did I say the mass was of the dirt? The dust particle. What did I say it was? No. No,
Wait.
I didn't say a mass. Well, we'll have to make one up, so.
20 grams, 50 grams.
No, it's a dust particle. Milligram would be better than 20 grams. That'd be a big blob of dirt floating up in the air. We'll say that, okay, so I didn't tell you this in the question. Let's just say the mass of the dust particle is 10 to the minus. Hang on, what did I say the charge was?
10 minus 10.
10 to the minus 10.
Probably 1 gram.
Okay, we'll say 10 to the minus 6. Yeah?
Really?
Yeah, we
For
will.
20 seconds.
Yeah. It's a dust particle, not a sandwich. It should be small, okay?
It's a long period of time.
It doesn't matter about that. 10 to the minus 6 times 0.0015 over 10 to the minus 10. So the E should equal 15 newtons per coulomb. Now I don't want the E, I want the voltage. So I can now use the formula E equals V over D. So what does V equal? Well, V will equal ED, which will equal 15 times what? 0.3. Yeah. Which is pretty small, 4.5 volts. That's probably unrealistic. I think I shouldn't have used 10 to the minus 6. I should have used something too big. I think to make this more realistic, I probably should have made the mass 10 to the minus 5 maybe. Because 10 to the minus 5 would make this bigger, which would make this bigger. Because a typical answer would be more like 45 volts, not 4.5 volts. So, it means when I do this with the January students, we'll get a more realistic answer. But it doesn't matter, it's the same way.
You didn't get this last year?
No, these are all completely new. Last year I just wrote stuff on the board. None of the,
We are lucky now.
you are lucky. You're a lucky student.
Yes, 45. You use 10 to the power minus.
Yeah, I know this, thank you. Of mass 10 to the power of minus 5 kilograms. Right, thank you for your input though, KJ, it's appreciated. Alright, we'll start the next lesson, so you can see this topic is not crazy difficult, but there are much more we have to do with fields. This is really just right at the beginning, but electric fields, we still have a little bit more to do with them, but they're not crazy difficult.